would like to thank you for giving your time and interest in joining this network services. DHCP and IPAM can be leveraged by food service sector to build a strong and effective infrastructure for providing seamless network service. This webinar is dedicated to IT professionals, restaurant stakeholders, restaurant owners, and also for they be implemented for benefiting in terms of network efficiency and security. You will be welcome to stay with us till the end of the session. So let's get started. Before we proceed with the webinar, I would like you to confirm in the webinar chat panel if you could hear me and see the presentation on screen. Let me introduce myself. I'm your host, Vikram Aditya, product expert for Manage Engine. I collaborate with the Manage Engine DDI Central and Cloud DNS marketing teams. I talk about legal network services, DNS, DHCP, and IPAM, and how much vital they are for increasing the operational efficiency, strengthen the security, and provide robust control over the network activities and complete transformation. Let us now go through the agenda for today's webinar. Firstly, we'll start to identify and understand the networking issues faced by modern restaurants and food service businesses with charts and real examples. Firstly, we start to identify and understand the networking issues faced by modern restaurants and food service businesses with charts and real-life examples. Then, we'll go through the key networking requirements demanded by food service sector for managing their network smoothly and effectively. Next, we understand how DDI solutions can involve in strengthening the network infrastructure with its features and policies. We'll then move on to explore the importance of network segmentation strategies and how necessary they are for compartmentalization and optimization of network resources. For effective food service operations, we'll then be understanding how real-time updating, monitoring, and connectivity mitigate network delays and errors. Then we'll explore how low latency connectivity enhances surveillance, IoT integration, and overall safety. For building service, we'll be understanding how automated failover mechanism is crucial for 24/7 service run. Cybersecurity is the topmost priority, and we'll talk about how DNS firewall policies and network segmentation help mitigate cyber threats and unauthorized access. Finally, we'll discuss how a robust IP infrastructure supports the longevity and efficiency of food service network support through real-life use cases. By the end of this session, you'll have a clear understanding of how modern restaurants and food service businesses stay connected, secure, and strong with the power of DDA solutions. Restaurants today are no longer just about serving food. They're also highly connected digital ecosystems, from online reservations and mobile delivery apps to digital payment gateways, Wi-Fi access, and smart kitchen technologies. Restaurants process vast amount of sensitive customer data daily. This includes personal identification details, credit card information, and dining preferences, all of which make them attractive targets for cyber criminals. The food service industry has become increasingly vulnerable to cyber attacks due to its reliance on interconnected systems. Many restaurants still operate with outdated POS hardware, poorly secured Wi-Fi networks, and inadequate network segmentation, creating multiple points of entry for hackers. Additionally, the high turnover of restaurant staff makes it difficult to enforce strict cyber security practices, further exposing restaurant networks and IoT devices to risks. Let's look at the common attacks in restaurants. POS point of sale hacks, which include restaurants' POS systems being the prime targets, with attackers installing malware on terminals to capture customer card data during transactions. These breaches often go unnoticed as the malware runs silently in the background while staff and customers continue normal operations. Data breaches involves restaurants storing large amount of sensitive data such as customer payment records, loyalty details, and delivery addresses. Weak network security or phishing scams can lead to breaches with stolen data, often so kitchen display systems and Wi-Fi networks can be locked or encrypted by ransomware. This disrupts operations, halts online orders, and prevents payments from being processed. Downtime not only impacts revenue but also damages customer trust and brand reputation. So here are some of the common cyber attacks and examples in the food industry. In January 2023, Yum Brands, the parent company of KFC, Pizza Hut, and Taco Bell, suffered a ransomware attack that disrupted IT systems across the UK. Nearly 300 restaurants were temporarily closed as the company shut down affected networks to contain the breach. The attack targeted internal IT systems, and while custom payment data was not initially thought to be compromised, Yum later confirmed that certain employee personal details may have been exposed. Though restaurants were reopened within a day, full recovery of the systems took longer. In June 2021, McDonald's in its operations after detecting unauthorized access in its internal systems, including emails, phone numbers, and delivery addresses, as well as the employee data. In South Korea, regulators later found McDonald's over $530,000 of data security that exposed information from nearly 4.9 million customers. Now, let us see the key demands of the modern food service sector. Restaurants can manage all network components from POS terminals, kitchen displays, guest Wi-Fi, IoT devices through a single centralized platform. This can simplify device onboarding, policy enforcement, and troubleshooting across multiple areas of the restaurant. A robust network ensures sensitive customer data, payment transactions, and inventory information which will be protected. Compliance with data privacy regulations build trust with customers while reducing the risks of costly breaches. Restaurant chains with multiple locations can connect kitchens, head offices, and delivery hubs seamlessly. Centralized management ensures consistent performance, secure access, and real-time coordination across all branches. Network admins can track traffic from POS systems, mobile ordering apps, and kitchen devices in real time. This helps prioritize critical operations, prevent congestion, and maintain smooth service for both staff. A well-organized IP plan ensures that devices like smart kitchen appliances, digital menu boards, and surveillance cameras are properly allocated and monitored. This visibility reduces conflicts, simplifies troubleshooting, and improves overall network efficiency. As you can see in this image, multiple brands of a food service organization are interconnected in a single network through private WAN network. In a restaurant branch environment, each individual restaurant will have its own LAN, and these LANs are connected to each other and to the headquarters through the WAN. This structure provides a high degree of communication and involves a high performance private WAN serving as the backbone. The backbone is often established using dedicated IP/MPLS routes or an optical core that interconnects all parts of the network with transmission devices, while the branches connected to it are connected via SD, WAN, SDN, or IP/MPLS augmented via VPN. This image represents how a single restaurant branch LAN network typically looks like, where both DNS and DHCP servers are managed individually. When a restaurant manages these servers separately, network administrators face challenges in implementing policies, troubleshooting issues, or updating resources efficiently. As restaurants adopt multiple solutions, software and services, such as POS systems, kitchen management tools, and digital ordering apps, network admins often struggle to manage an integrated network infrastructure and secure all network resources effectively. The primary challenge for network admins is to converge, manage, and monitor the entire restaurant network under a unified IP infrastructure. This is where DDI solution can help. Implementing a DDI solution can help address this challenge by providing a centralized platform that allows network admins to efficiently manage the DNS, DHCP, and IPAM services, streamline operations, enforce policies, and maintain security across all devices and services within the restaurant. Now let us understand what DDI is and how it is recommended for organizations to strengthen their network infrastructure, optimize network resources, and effectively manage their network services. DDI is the network solution comprising the three core services DNS, DHCP, and IPAM into a single management platform, helping admins have a greater view and control over the network and its resources. With the DDI solution implemented, network admins can do the following thing, that is, discover and manage DHCP scopes, dynamically DHCP fingerprinting policies for devices, manage DNS zones, domain views, and DNS records, set up DNS security policies, analyze real-time DNS query traffic, review DNS and DHCP audit logs, and manage dual-stack IPv4 and IPv6 address inventories. All of the above can be handled in a single window, reducing the need of jumping into different individual solutions for DNS and DHCP operations. Manage Engine has its own DDI solution called Manage Engine DDI Central, a user-friendly centralized platform that unites DNS, DHCP, and IPAM for an improved management and security of the food service operations. This strengthens the stability and reliability of the organization's network infrastructure. DDI Central manages your existing Linux-based IAC by 9 and IAC DHCP installations and can also set up new DNS and DHCP clusters. It can also manage your Microsoft Windows DNS and DHCP clusters, and this webinar gives you detailed understanding over its features, policies, and benefits. To make it more interesting, DDI solutions help easily manage the three services configuration of each restaurant that are already connected to the organization's network via technologies such as SD-WAN, IP-MPLS core via VPN, or even through dark fiber cables. When you onboard your restaurant branch's DNS and DHCP clusters into DDI Central, it starts to discover all your configurations on a granular level for a clear visibility with real-time data. DDI Central's UI organizes all the configurations, making it easy to control the core services and make changes when needed. Analyze the real-time valuable insight over each DNS and DHCP clusters to gain visual summary for quick troubleshooting. Food service network admins can manage and view their core services distributed across different branches, all in a single window. Network admins can add DNS and DHCP servers of each restaurant branches and data centers as separate clusters, in which the data can be discovered and displayed through the common dashboard. Here, you can view the health and performance of your services, the total usage of each network resource, and get alerts for any network issues. This dashboard provides admins with a contextualized view over the network for quick detection and troubleshooting of issues. Role-based access controls in DDI Central allows network admins to grant access to individuals in the organizations based on their respective roles. In RBAC, we got four roles, two primary administrator and operator roles, and the other two roles are only for monitoring purposes. The admin role provides access to all the clusters and settings, while the operator role provides specific access based on the individual's responsibility. The permissions can be limited on cluster-based, service-specific, which is DNS, DHCP, or both, for every individuals based on their hierarchical roles. By providing this flexibility in permissions assignments, this DDI Central ensures that individuals have just the right level of access to perform their tasks effectively, while maintaining security and minimizing the risks of unauthorized changes. The network segmentation plays a critical role in the food service industry, where large and complex networks support a wide range of services, from VoIP communication, mobile apps, point of sale systems, and staff communication tools. Each function requires its own secure and effective network environment. Segmentation ensures that customers, staff, and management connect only through the resources meant for them without disrupting other services, causing conflicts. Without automation, managing such a diverse network manually would require a large team of admins, which is an impractical and costly approach. This is where DDI solution becomes indispensable. With a platform like DDI Central, food service businesses can easily segment their networks, enforce service-specific policies, and streamline management. In the event of network issue or a security breach, segments confines the problem to the affected section, preventing it from spreading across the business. This containment not only limits downtime but also safeguards critical systems, ensuring that operations like transactions remain uninterrupted. Food service businesses rely on a wide range of connected devices such as kitchen display systems, customer facing Wi Fi, digital menu boards, mobile ordering apps, POS terminals, and staff communication tools. To maintain smooth operations and prevent issues like IP conflicts or overlapping subnets, these devices must be properly segmented and managed through efficient IP leasing. The structure or division of the network is known as network segmentation. In restaurants and food service chains, this segmentation can be seamlessly managed with the DHCP Scope Manager in DDI Center. With this feature, admins can assign dedicated DHCP scopes for POS systems, kitchen devices, surveillance cameras, or IoT-enabled equipments like smart ovens and temperature sensors. Let's see how it's done in DDI Center. Here in DDI Central, you can create subnets with the specific pool ranges for specific devices and machines in your food service network, like cameras, routers, POS systems, VoIP phones, and etc., which helps in segmenting different departments without overlapping. You can also create static subnets of different pool ranges to ensure leasing is done for specific defined devices and prevent DHCP from leasing for general uses. This is a way of separating from other subnets and providing a specific purpose for leasing. You can add different subnets with different pool into a single supernet for admins to organize multiple subnets in a hierarchical method for an easy visual breakdown. Admins can combine multiple different subnets and define configurations with DHCP options or custom options with the help of shared network. You can categorize certain subnets to be under a VLAN and describe their purpose. Here, you can assign fixed IPs for critical devices with the help of DHCP's host reservation. And it's important to note that SuperNet and VLAN helps organizing subnets to make admins simplified, and there won't be any configurations available for both of them. In the IPAM module, you can view the entire IP inventory of the configured subnets. And when you go through specific subnet in IPAM, a donut plot provides a visual summary of the number of IPs in the subnet and their availability status, helping admins in optimizing the IP address utilization. It also helps during IP address conflicts, where admins can find and click on the available IP and allocate them as a fixed IP to one of the conflicting hosts for quick resolving, thus providing hands-on control over the IP inventory of the subnet. Let us consider a restaurant chain hosts a website called silkerfoods.com with generic information regarding its menu, pricing, offers, online ordering, and etc. That also compromises confidential information such as food inventory, supply details, and employee records, which should only be accessed by the when an external visitor tries to access the website, they should only be accessing the ordering and menu information, while when a staff member accesses the website, they should be viewing the inventory and internal data. So, the restaurant management needs to separate the domain resolution for the website to secure their organizational data. Here is where DNS views or domain views play a crucial role in separating resolution for different departments. Network admins can customize DNS response for the same domain for different groups, enforce network security, and increase control over access to different segments within the organization's network. DNS views consist of internal and external view match lists. The internal view match list includes IPs and subnets that belong to the restaurant's internal network. Typically, the IP ranges assigned by the internal DHCP servers that employees connect to. The external view match list is usually defined as catch-all, meaning it matches any public IP that does not fall within the internal range. When the IP matches the internal view, it resolves to the inventory and staff portal that can be accessed by employees. And when the IP matches the external view, it resolves to the customer-facing food ordering website. This way, organization can implement network segmentation in DNS resolution process, ensuring specific responses to clients based on whether they are customers or internal staffs. The domain query analytics allows you to analyze queries to the views along with the hosted and non-hosted domains. You can view the visual summary of the number of queries to the views and domains for a specific time interval and the number of queries received for a specific IP address. Select a specific domain or view in the list, which displays metrics of the domain's performance, including hourly query load over a time frame. You'll also see details for IP addresses leased under a domain, such as lease duration, MAC addresses identifying each host, and the vendors of the host machine. You can see donut charts for total query load across all IPs and for individual query load, which can be accessed by clicking on specific IP. Moreover, a specific donut chart provides a visual breakdown of the query volume for different types of DNS records, showcasing the query distribution for each record. And when you click on a specific record type, you can view the list of all zones queried for that record type. This list includes hourly query loads, queries per second, and the total number of queries covering the zones associated with the record. You can also drill down to a specific zone by clicking on them to view insights of the zone's records. DDI solutions offer comprehensive built-in logging and reporting capabilities that aid in compliance with regulations like the GDPR, PCI DSS, and ISO IEC 27001, and more. DDI Central captures audit trails of every action executed on each and every object managed by the DNS and DHCP servers. You can choose the relevant subnets or zones and report the audits of the only those segments to the regulators. This saves time and reduces costs compared to the reporting full network audit. DDI Central enables you implementing failover mechanism for both DNS and DHCP services of your organization, help in maintaining consistent services even when service goes down. For both DHCP services, when configuring a subnet, you can add one primary and add as many secondary servers based on your requirement. The same applies to DNS services where you can add a primary and secondary servers for a specific domain. In case the primary goes down, the secondary server steps in to take full responsibility for continuing the service and handling the network traffic. Enter the relevant value in the spread field. For example, a value of 128 here indicates a 50-50 load balancing actively involving both primary and secondary servers to handle the DHCP traffic. IP address management in DDI Central collects and links DNS and DHCP data across all clusters, offering a clear contextual view of network services. It acts as the network source of truth, helping admins make informed and data-driven decisions. Key metadata like DNS records, DHCP leases, and IP allocations are visualized through charts for easy analysis and troubleshooting. In the DHCP leases section, admins can see a graph showing the number of leases assigned per hour. A table displayed detailed info such as IP address, lease period, status, assigned MAC address, hostname, vendor, and connection type. DDI Central combining the three core services in sync will make it easier to set up end-to-end automation involving them, thus making it an automation hub. Here are the following key processes that can be automated using DDI. You can automatically assign IP address to hosts with DHCP server through client class, enhancing the efficiency of network and ensures that IP resources are utilized properly, preventing IP exhaustion. Dynamic DNS feature in DDI Central automatically updates the DNS records whenever the IP addresses change. This ensures that the domain is always available to access easily. DDI systems automatically detect and resolve IP address conflicts and maintain an updated IP inventory, ensuring reliability and preventing downtime in food services. Scheduled DHCP scopes and DNS records allows network admins to go on a schedule it and forget it mode, enabling them to plan and implement network expansions or updates at the predetermined times for maintaining uninterrupted service. Scheduled DNS DHCP report from time to time gives admins a real-time data of subnet capacities and zone query analytics for better utilization of IPs. DNS is considered as the first point of contact in a network, so DNS firewall constitutes the network's first line of defense. Following a layered approach, it imparts self-defending capabilities to networks by placing strategic defenses against unwanted intrusions. It actively blocks malicious activity using domain blocking and mitigates ongoing attacks with its response. How DNS firewall works. DNS query resolution policy in DDI Central for Windows and Microsoft servers help in configuring query responses and redirecting queries to specific network segments based on the criteria such as time, internet protocol, and transfer protocol. DDI Central's Windows Microsoft enables you to configure DNS response for different applications or service by defining the zone scope and also implement split brain configurations, where you can separate responses for internal and external queries. This helps admins manage their network traffic and segment the responses for different departments of the organization. This also helps in preventing DNS-based attacks. You can configure the QRP in Windows by going into the DNS firewall and selecting DNS QRP. Here you can create your own QRP by clicking on the Add QRP option and provide details in the field such as name, criteria, condition for matching and not matching. DNS firewall's response policy zones in DDI solution allows you to customize the responses for recognizable domain name by implementing security measures such as blocking malicious domains, redirecting users to safer page, and also applying custom policies. The query sent to the RPC domains is further analyzed by DDI Central based on the configured RPC policies. And when it matches the policy, the query will be resolved to the custom IP. And when it doesn't match, it gets blocked and user gets redirected. You can enable RPC by selecting the domain type where a new domain can be created. An RPC can be created in the DNS options section by clicking on response policy. The RPC also logs the queries to block domains, providing valuable insights into attempted access to harmful sites and helping to identify patterns of the malicious activity. DDI Central enables you to apply a variety of DNS options to RPCs to have a granular control over the clients accessing it. Restaurant consists of multiple interconnected devices in their network environment, from digital menu screens, kitchen display systems, and POS terminals to smart lighting, climate control systems, security cameras, and IoT-enabled kitchen appliances. Each devices provide critical services that enhances customer experience and streamline restaurant operations. This means that identifying devices and allocating IPs to the right devices, which require constant connectivity, can be tedious for network admins. With hundreds or even thousands of devices connecting and disconnecting across dining areas, kitchens, drive-through systems, back office operations, manually managing IP become chaotic. In DDA solution, which with their policies and configurations, simplify it can be simplified. Network admins can either assign a fixed IP for a particular IoT device through the static subnet or configure it to automatically allocate as a fixed IP when a device joins the network via DHCP host reservation. With host reservation, the server automatically assigns an IP address to the specific device upon joining the network. VLANs can be defined and VLAN-aware DHCP policies can be implemented to seamlessly integrate IoT devices while isolating their broadcast traffic from the rest of the network, protecting them from potential cyber threats. DHCP reservations further enhance this setup by ensuring that critical devices such as POS terminals, kitchen display systems, security cameras, and routers always receive consistent IPs without the admin overhead of static assignments. Finally, if you have two different devices in the separate subnets but need similar configuration, you can add both subnets into a shared network and apply a common policy to both. Similarly, two devices requiring the same configuration can be managed within the same subnet for efficient network administration. Let's consider a scenario where a restaurant employee has clicked a link with a crafty phishing email and unknowingly gets his or her system infected by malware. Upon connecting to the restaurant's private network, the malware tries to covertly access malicious sites using the DNS resolver. DD Central easily manages such situations with its DNS firewall. This firewall maintains a blacklist comprising a recognized collection of undesirable domains. Before the resolver can provide the actual IP address, it checks the domain against this blacklist. If there is a match, the resolver does not proceed to fetch the real IP from the external authoritative DNS server. Instead of connecting to the malicious site, the user is redirected to a safety page. By clicking on the DNS firewall in config section, you can provide the domain name to be blocked, category for blocking, and also the redirection IP to redirect clients to a safer page. You can also view the domains blocked and domains blocked domain subdomains in the bottom, and you can view the blacklist of malicious domains here with the categories. And this data can be imported as a CSV format. DDI Central's Query Analytics provides network admins insights on who sent queries on blocked domains and how many times the queries were sent. In the big tabular column, you can see the details about the query request on malicious domains with the record type, IP address, host details, and date and time. You can identify the host machine from which queries were sent through their name or their device's MAC address. Moreover, in the small tabular column, you can see how many queries were sent for that particular block domain IP, alongside a chart view of the total queries per IP. Imagine a popular restaurant chain where hundreds of customers connect daily using personal smartphones, tablets, and IoT-enabled devices like digital menu screens, smart kitchen appliances, and ordering kiosks. And one day the restaurant's DNS servers start receiving an unusual volume of queries, triggered by a botnet-based DNS amplification attack. Here how it's unfolded. Attackers spoof the IP address of the restaurant's internal systems and flood the DNS servers with small repetitive queries. Normally, the DNS would respond to each query, and because the responses are larger than the requests, this creates a flood of amplified data aimed back at the restaurant's critical backend systems, threatening to disrupt customer Wi-Fi, mobile ordering apps, POS terminals, and even kitchen or staff communication systems. This type of attack is known as a distributed denial of service or DDoS attack. These threats can be instantly identified using DDI Central's Query Analytics tool that visually charts unusual spikes. To mitigate the DDoS attacks, the response rate to any individual IP address. This way, it prevents the DNS servers from being used as amplifiers in DDoS attacks. The response rate limiting is a DNS security feature that intelligently regulates response throttling to mitigate the impact of DNS amplification attacks, ensuring uninterrupted access for legitimate clients and upholding a well-balanced approach to security. It facilitates a selective response mechanism that ensures your network is not only resilient against attacks but also remains efficient and reliable for legitimate users. Response rate limiting can be accessed in IAC bind by selecting rate limit in DNS options, which provides several fields to fill in details like all per second, errors per second, prefix length for IPv4 and IPv6, and more. You can also provide the IP of clients you want to exceed from this list in the XM's client field. Selecting the DNS RRL in configuration section, you can able to modify the DNS RRL settings by editing the values for your needs. You can also provide the IP of clients you want to exceed from this list in the XM's clients list section. Restaurants handle high sensitive information, including customer orders, payment transactions, inventory data, and internal operations, all of which must be protected from unauthorized access. At the same time, restaurants need to provide seamless and secure connectivity for staff devices used by kitchen teams, servers, POS terminals, and back office employees. May require secure remote access during critical situations. This means the restaurant network must strictly identify and connect only authorized staff devices to operational systems while preventing unauthorized customers or external services. For example, staff devices should be access to inventory managed systems, POS terminals, and internal restaurant applications, while customer devices remain restricted to ordering apps. DDI Central addresses this challenge through DHCP policies. Network admins can create specific client classes to recognized staff devices based on their MAC address. Identified, these devices are automatically classified into separate client class and assigned IP addresses from a restricted subnet dedicated to restaurant staff operations. This ensures that the staff devices have secure access to operational systems while customer devices remain completely isolated. For instance, a client class like restaurants op staff can be mapped to a subnet example 10.10.50.0/24 where all verified staff devices are enrolled. DCP policies can include MAC address verification, DNS update styles, and domain names, ensuring that only approved devices receive IP allocations for this subnet. If a device outside the authorized MAC list attempts to connect, access will be denied, safeguarding the restaurant's critical systems from intrusions. This client class segmentation not only enforces secure access control but also improves network efficiency, giving restaurant IT teams clear visibility into which devices belong to staff and which belongs to the customers, eliminating risks of accidental crossover or malicious access. As we conclude today's sessions, it's clear that restaurants are no longer just about food and ambience. They are digital ecosystems where every customer interactions, every kitchen operation, and every connected device depends on the strength of the network. From seamless guest Wi-Fi and mobile ordering to POS systems, digital payments, and online reservations and smart kitchen equipment, a reliable and intelligent network ensures that the entire dining experience runs without interruption. This is where modern solutions come in, streamlining IP address management, automating critical processes, and giving IT teams the visibility and agility they need to keep operations efficient. In short, investing in the right network solutions today empowers restaurants to stay connected, stay secure, and stay ready for tomorrow. Thank you for taking the time to be part of this webinar. Right after the session, you will be directed to our downloads page where you can start your 30-day free trial today. You can also visit our demo page where we have a live interactive demo up and running for you to explore and play around with. If you have any queries, please shoot us an email at ddi-support at managengine.com. This is your host Vikram Aditya signing off. Thank you.